So, good evening. Today we are going to see about the two types of signals. That is, one type is called periodic signal and another type is called non-periodic signal. So, we are going to today class we are going to see about the periodic signal. Periodic signal. Second one is aperiodic signal. You know well about this because in the type of the system, in the type of the signal, these are the two types of signals. One is an periodic signal and an aperiodic signal. Not only these two types, but we have more types. But in this today's class we are going to see only the periodic signal and aperiodic signal. So what is a periodic signal? So let us see what is a periodic signal. So in that word itself, we can identify that periodic. What is mean by the periodic? We will have a continuous with a equal periodic of time. That means, so it start with a 4, means again you will get it as again the 4 minus 4, 4 again minus 4, like that it will get an periodic value. It will not changes. It will not changes in other waveform, like that. So one more thing, the waveform of the signal is in periodic only. It will not change the time interval. If it continues with the 4, it will keep on going with the 4 only. So it is called as a periodic signal. As the name is aperiodic signal, it does not have an same interval of time. It will have a different interval of time. Okay, so this is called as an aperiodic signal and aperiodic signal. Now you can understand what is a periodic and aperiodic signal. One more time I am repeating, the periodic signal, as it's the word means that there will be a repeated time interval for all the signals. But in the case of aperiodic signal, there won't be a repeated time interval. Okay, this is called as a periodic and aperiodic. So first of all, we can see the definition. A signal is said to be periodic when the signal should be when the signal is be periodic signal. So it if gets repeated for every finite interval of time. Every finite interval of time, it is called as a periodic. And one more thing, and we can say it as, if the x of n is equal to x of small n plus the capital N. The small n means the values of n. So the n of the values or values of n. Okay, so if the condition satisfies this equation, x of n is equal to x of n plus 1, when it is equal, so we can call it as an periodic signal. Okay, and how will be the periodic signal means, if it is in continuous signal. Already you know what is continuous signal and what is a discrete signal. Normally the signal is divided into three types. One is in continuous signal, another one is in digital signal, another one is a discrete signal. Okay, so digital signal, discrete signal and continuous signal. First of all, you want to know what is a continuous signal. Okay, so when you having a continuous interval of time, it is called as a continuous signal. Okay, you know already what is a digital signal. It means that you will get then zeros and ones value. So if this is a 1 and this is a 0 and this is a 1 and this is a 0, like that you will get in digital values. That means a binary value. It is called as a digital signal. When you are going for the discrete signal, it will act like a particular time interval, like this. The particular time interval, it will have a process. This is called as an discrete time signal. Okay, so in the subject we are only concentrating on the discrete signals. Okay, not a continuous, not a digital, and we are going only the discrete signals. Okay, so it will process at the particular interval of time. Likewise, there will be a sequence of numbers 1 2. If the one is a process, it will processing, and then there will be some gap, and the second thing, again when they having the second process, there will be some time interval, and it will act as then it will do the process, and the third and fourth, like that it's keep on going on the processing. This is called as a discrete signal. So in our periodic signal, because in our subject digital signal processing, you know already what is digital signal processing. So if you want to convert your signal analog to digital, you have to go for the digital signal processing. Why we are going for this digital? Because for example, we in the traditional age, what we have did is, if you want to measure that temperature, or if you want to measure that pressure, these are all things is with the help of analog signals. So nowadays the technologies had a wide have a wide thing to overcome that analog thing as and digital. You know already digital is zeros and ones. So it changes the revolution, like changes the analog to digital. If you want to convert your analog signal, you can use the digital signal processing. You can sense the information, or you can say you can send the signal to that digital filter. It will convert into the digital signal processing. And you know one thing, what is a signal? And the signal, you know already, the signal is nothing but it will carry the information from one place to another place. That is called as a signal. You know very well about the signal, right? So signal is nothing but it will carry the information from one place to another place. So in our subject, we are taking the information. That means we are taking the information from one place to another place with the help of digital signal processing. Here we are taking the analog signal and converting into the digital processing, because for the more accuracy and for a more efficient result, we are going for this digital signal processing. Okay, now so I have gone for a lot of basics things, and we just continue with our periodic signals. The periodic signal is said to be periodic if it gets repeated for every finite interval of time. So already I said, if you're having some like in a 4 as an height of this waveform, so it will keep on goes with a 4. So that is called as a periodic signal. Then when the problem have to satisfies this equation, that means x of n is equal to x of n plus 1. When it is equal, we can say it as a periodic signal. And then we are going for the aperiodic signal. Okay, now what is aperiodic signal? What does aperiodic signal? So already I said, the signal is said to be, when it is said to be aperiodic, means it does not repeat. Okay, it does not repeat at definite interval of time. Definite interval of time. Okay, so aperiodic is nothing but it does not repeat. When the signal is to be aperiodic, means it does not repeat at definite interval of time. Now we are studying about the discrete signal. So I can give you example for discrete thing. For example, like this, it won't be a repeating interval, it may be like this way. Okay, this is called as an aperiodic signal. And how to satisfy in the mathematically, how can we say this with this relationship in aperiodic? Means x of n is equal to x of is not equal to x of n plus n. So n plus n for all n. Okay, so aperiodic is nothing but it does not repeat any definite interval of time. It does not follow any interval of time. It will have a random values. So and mathematically we can say that a periodic signal is x of n is not equal to x of n plus n for all n values. Now we are going to do 2 problems or 3 problems in how to check a periodic or not. Okay, first of all we will check the answers. So first question is, check whether the given signal are periodic. So check whether the given signal, the given signals are periodic or not. So we are going to take a simple problem, and I'm going to give you some explanation about the problem. Okay, x of n. So we are studying about the discrete value. So our denotation would be x of n, and if you want to do it in x of t, that is called a continuous signal. If you want to say it in x of n, it is called as an discrete signal. Okay, x of n cos pi by 4 n plus sine pi by n. Okay, this is a question. So we have to find out for the separate terms. Okay, this is one term and this is one term. So we first of all we will see what is in the first term. I'm taking the omega is omega 1. This is omega 1 and this is omega 2. I'm taking that in the value of n is pi by 4. Okay, we know already that. So we know the formula for omega 1 is 2 pi f1. Why I am mentioning 1? Because I am taking the term 1. So I have mentioned here as omega is equal to 1. So I am taking here as a 2 pi fn 1 is equal to pi by 4. We know already this formula, we have learnt in the before class. So now I have taken directly the 2 pi fn f1 divided by 1 by 4. So now we can take it the formula. So 2 pi f1 is equal to pi by 4. So f is equal to 1 by n. I have changed here 2 pi by n. So we are denoting with the first term as a 1. So I am putting 1 is equal to pi by 4. So in the next term, what I am going to do, so for making this n1 as a smallest integer, I am multiplying the m1. m1 is a multiplied. Okay, so I multiplied with this term. So 2 pi n1 into m1, because the term is m1, and why am I multiplying this m means that I'm going to make this n1 as a smaller, so I'm going to multiply it by 1 by 4. So sorry, so we have to put the pi. So see, this pi and this pi will get cancelled, and this 2 and this 2 will get cancelled, and you will get it as a 2, and here is a 1. So what happened here is m1 divided by n1 is equal to 1 by, so m1 divided by n1 is equal to 1 by 2. So here therefore m1 is equal to 1 and n1 is equal to 2. Without getting the pi values, if you are getting the constant value like 1 and 2, it's said to be an periodic. Okay, this part is an periodic, and now we are going to do it for the second part is a sin n. Okay, sin n. So sin n, how to take the omega value? So the n is, if there is a no number, you can take it as a 1. So omega 2 is equal to 1. We know already 2 pi f2 divided by 1. And what is the formula for f2 is equal to 1 by n2. So 2 pi 1 by n2 is equal to 1. And for making this n2 as a smaller, so I am multiplying 2 pi divided by n2 into m2 is equal to 1. And so what happened is m2 divided by n2 is equal to, so I bring this number to the left hand side as a 2 pi. So what happened is the m2 is equal to 1 and n2 is equal to 2 pi. So if the number which combines with this pi value, we will not get a periodic signal. So it is called as an aperiodic signal. So I hope you can understand this thing. We can do the next more problems in the next for coming classes. Yeah, thank you.